So I've been working on expanding the GPIO ports on the Raspberry Pi. I've ended up going for 8-bit port expanders. The actual unit is a PCF 8574, which are really common, cheap little i2cs. I think I paid about 80p each. They run on the i2c bus, which is just a little communication interface that works sending binary signals. It's just on 2 wires, so it's these 2 wires here. Everything that the signals go up and down to control everything, and then we've got the 2 power wires here, which is obviously a positive and negative. A Raspberry Pi over here, Pi cobbler, which is just a nice easy way to take all the GPIO pins across onto a breadboard rather than trying to plug pins and bits and pieces onto the Raspberry Pi. And over here we have the main setup. So we have, you can see the 2 port expanders. We've got 8 LEDs with resistors and transistors wired up in there, so there's 1 LED per port, so we can switch bits and pieces off. And we've got exactly the same setup again, apart from one minute difference. Each chip has its own binary address, and the address is set by the first 3 pins. So if we try and look across here, we've got 3 wires here wired up to the first 3 pins. They go to the ground. This sets the address of this unit to 56 in decimal representation. Then if we go over to the other one here, it's all a bit cramped, but you can see there's 2 wires here going down to the ground, and then we've got 1 wire here. This is the difference. This wire goes over to the positive, so that sets it at a different address, which is actually 57. So I can address each chip. There's a combination of 8 different addresses, so you could potentially put 8 of these chips onto just one IC2 interface. Okay, let's put the camera back. So everything I've written is in Python. It's developed as just one single object with different methods to it, so you can do all kinds of things just with one object, which makes it nice and easy. You should be able to put it into other programs easily, do what you want with it. I've also made a command line interface, so you could just call things up with options on the command line, and you can do all your bits and pieces just straight from the command line. Okay, so what we can do is I can select the chip with the address of 56 and open all the ports. There we go, everything lights up. I could close them, so close all, and they close. I could write them again. I could go to the 57 address, so it's just changing one little parameter of 57, and then write all, and they'll come on. Okay. What I can also do is I can switch individual ports on and off. So on the 56 port 0 we could switch off, there it goes off. We could do the same for port 1, port 2, we could switch port 1 back on again. There we go. And we could do the same on address 57. So we could go like that, and there we go, one of them switches off. I've also got another bounce, which looks like this. So 56 goes onto the bounce, and it bounces backwards and forwards. And stop that. We could do that on the 57. There's also a parameter to set the speed, so I can make it go really fast. That's really fast. Let's stop that. Could also, on the other side, make it go slow if I wanted. There we go, switching nice and slowly. I've also made it so it'll just chase in one direction, so on the 56 side we can do that, leaving the other side running, and make it chase left. And there we go, it's chasing along left. Can stop that. Can do the same, make it chase right. There it goes, ridiculously fast. Maybe I'll just slow that down a bit. Let's go. And there we go. All my code's up on Bitbucket. There should be a link below this video to download the code, so you can just play about with it, try and expand it if you want.